In this next unit, we're going to go over the rules of differentiation that we've learned so far, and then we're also going to learn some new rules. So, let's say that we have u and v, they're both functions of x. You're probably used to saying f of x or g of x. So we're going to have, instead of f and g, we'll just call them u and v. So we have u of x and v of x. And then c is any constant. So we've learned that the derivative with respect to x of a constant is going to equal 0. Because if you graph a constant function, that's horizontal. And so drawing a tangent line at any point on that horizontal line will also be horizontal, so the slope of that tangent line is 0. If we try and do the derivative of a constant times a function, c times u of x, then the derivative is just going to be that constant times the derivative of u of x. So c u prime of x. And then also, if we want to take the derivative of a function u of x plus another function v of x, then we can take the individual derivatives and add them together. So the derivative of the sum of two functions equals the sum of the derivatives of those individual functions. And then we learned the power rule. And that said that if f of x is equal to x to the n, where n is any real number, then f prime of x, or the derivative of f with respect to x, is going to equal n times x to the n minus first power. So the rest of this lesson, I just want to go through some examples and practice these rules. Find f prime of x for f of x is equal to x to the 7th power. All right, well, the power rule says we take this exponent, we multiply it out in front, and then we reduce it by 1. So it's going to be 7 times x to the 7 minus first power, or 7x to the 6th power. Easy enough. Let's look at another one. How about finding the derivative, dy dx? Notice that's just a different notation, but it's the same as saying f prime of x up here. So find dy dx for y is equal to this polynomial. So dy dx, or we could just write y prime if we wanted. So let's apply the rule here. We're going to take the 4, we're going to multiply it out in front, and there's a 5 out in front. So we do 4 times 5 is 20, and then we're going to lower the exponent by 1, so 4 minus 1 is 3. Minus, same thing here, take the 2, multiply it out in front, 2 times 3 is 6, and then lower 2 by 1, 2 minus 1 is the first power. Now obviously we're not going to write the first power, but just to understand how we're applying this rule. The next one, 8x to the first power, so we multiply that out in front and we get an 8, x to the 0, which is just 1. And then the derivative of a constant is 0. And so you don't have to write minus 0, but realize the derivative of any constant is equal to 0. So there's dy dx. Let's look at another one. Differentiate with respect to x for f of x equals 2x to the pi. You might want to hit pause on this one, give it a shot, and then check your answer. Okay, even though it looks different than the others, we still, apply the same rule. So the exponent is pi. That's a real number. So we multiply that out in front and lower it by 1. So we're going to do 2 times pi, and then it's going to become x to the pi minus 1 power. And that's it. Sometimes don't make it more complicated than it really needs to be. All right, how about this one? Find v prime of n for v of n equals the square root of n plus 1 over n plus 1 over n squared. Now, what I want to do first is let's rewrite this with exponents instead of fractions, and instead of a square root. So the square root of n is the same as n to the 1/2 power. 1 over n is the same as n to the negative first power, and 1 over n squared is the same as n to the negative second power. Now we can go ahead and apply our power rule So we multiplied the exponent out in front, so it's going to be 1/2 n, and then subtract 1. So 1/2 minus 1 is a negative 1/2. Okay, the next term, multiply the negative 1 out in front, so we get negative 1 n, and then subtract 1. Negative 1 minus 1 is negative 2. And then for the last term, negative 2, multiply that out in front, and then lower the exponent by 1. Negative 2 minus 1 is negative 3. Now you can write your answer like that, and that's fine. Or if you wanted to, you could write it as 1 over 2 times the square root of n. So 1 over 2n to the 1/2, or square root of n, minus 1 over n to the positive second power, minus, now the 2 doesn't have the exponent of negative 3, so the 2 is in the numerator, and then n to the positive 3 is in the denominator. So that would be fine as well. All right, the best way to get good at calculating derivatives is to practice following these rules. So your assignment set is 12A. There's a ton of problems in 1, 2, 3, and 4, so I just picked out a few that should give you some good practice.